So I'm going to stand here, which is awkward for me because I'm a pacer. It's an anxiety control issue, but I'll stand here because this mic picks up the live stream. So hey ho out there in live stream world. And there's one message I want to get across to you today, and I'll say it now. We need to build new mines for all metals at a pace or speed never before done by humanity. And we can do it, and we must do it. That's the message I want you to take away. So if you're sitting here today a little anxious about mining, right, a little neutral about mining, I'm hoping to convince you over the next 45 minutes-ish that you have to advocate for responsible mining. I'm not asking you to give mining companies a free pass to do whatever they want to do. I'm asking you, as a member of our global society, to advocate for mining companies to be able to increase exploration, which will increase the success of discoveries or discovery rate, and to significantly reduce the length of time it takes for mines to become permitted. And here's what I'll tell you. If you're opposed to that, you're elitist, you're racist, you're an ethnicist, and I'll tell you why. Okay? So, with that, I want you to look at the slide. The first slide shows you where we are today. And the collective we have come an incredibly long way since we evolved from tree-dwelling animals. Right? So if you imagine life at any point in the history of humanity, it was not as good as it is today. And I make that statement unequivocally, categorically. Life throughout the history of humanity was not as good as life is today. And we forget about that. We're a victim of the success of our ancestors. And I'm going to play a video now that I just want you to watch. And if it's intuitive, that's great. If not, I'll contextualize it. And I'm hoping the sound works. Just make sure before I turn this on. Yep, it's got volume up. Okay. Here is us in 2022.
In daylight, our big blue marble is all land, oceans, and clouds. But the night is electric. Seen from space, our planet comes alive with light. This new view of the Earth's night lights is a composite of data acquired by the polar orbiting SUMI NPP satellite. Aboard the satellite, a newly designed instrument called VEERS is able to collect what scientists say is a remarkably detailed view of the Earth at night. In some places, city lights resemble solitary stars in the night sky. In other places, dense clusters of galaxies. The satellite can even distinguish brightly lit boats that line Egypt's Nile River, and the massive flames from gas flares produced as a byproduct of oil and gas exploration in the Middle East. As the satellite passes over the darkness of the Himalayas, it shows how human settlement is bound by natural borders. Even political borders are starkly visible in this view of North and South Korea, and in a line of fishing boats that dot the Yellow Sea. But not all light is electric. Glowing just as bright, flaming wildfires burn across Australia. This new view of the Earth at night offers a unique perspective for exploring the many places in which we live and seeing the impact of human populations around the world, no matter how faint or how bright their lights shine.
So this is where we are now. And we're not going backwards. We're not going to go back to a time with no lights. So what I want to start out with is that universal truth. We are who we are today. We have, we continue, and we will always make mistakes. The wildfires are one example of a mistake that we caused. And we're learning from our mistakes. So today I want to talk about a few things. Carbon neutrality, which comes up a lot. I think most people don't actually understand what it means and what it requires. Resources, specifically the resources required to make carbon neutrality possible. Prosperity, that I will tell you as a white man in the United States, I often forget about until I engage with people from other parts of the world who remind me with an abrupt slap in the face how good I have it and how good everyone has it in the global north. And then some other musings. So the first book that I really read as a kid is the Old Testament. I think everybody should read the Old Testament. It doesn't matter if you're religious. It doesn't matter what religion you claim to belong to. But if you read the Old Testament, the Hebrew Bible, as an historical text, it is a lot of good, bad, and ugly. And in the Hebrew Bible, there are what we call the 7 metals of antiquity that are actually written in the Bible. Gold, copper, silver, tin, lead, iron, mercury. The collective we, or our ancestors, knew about these metals before the time of Jesus, if you believe in Jesus. And it was our ability to see these metals outcropping at the surface or in stream sediments, and to take those metals and make them useful for us, that distinguishes us from all other members of the animal kingdom. Nobody else does that. There are primates that use tools, right? There are primates that will take rocks and throw rocks at eggs to open the eggs up. But we're the only member of the animal kingdom that looked around, saw these metals, and said, how can we use them for us? And in some, it was simple. Gold was valuable. Simply having gold, we assigned value to it. We made jewelry from it. We used copper to transition from the Stone Age to the Copper Age. And we started making tools and kitchen items using copper. And then the Hittites and the Assyrians figured out, likely by accident, that if you mix a little bit of copper, well, a lot of copper, with a little bit of tin, you can make the metal bronze. And we transitioned from the Copper Age to the Bronze Age. And then owing to climate change and wars, we transitioned out of the Bronze Age into the Iron Age. We learned how to smelt iron. Today we know a periodic table that has 92 naturally occurring elements, 86 of which are metals. So in only a few thousand years, we went from using stones as our tool to now using 86 elements in the periodic table. That's our new built environment. And I look at that and it blows me away. I think it's absolutely awesome. When you read the Old Testament and you read about how individual groups moved from A to B to C to D, this was why. Right? Why did trade routes evolve? When you look at ancient maps of Algeria, when you look at Timbuktu, when you look at the trade route that became the Silk Road, when you look at ancient Turkey, Anatolia, and you see little dots seemingly in the middle of nowhere. The reason those dots are there is metals outcropped at the surface, and our ancestors learned to mine those metals and use those metals to build tools which were valued by society. So where are we now? Think about life at the year 0, 1000 BCE. It was good to be the king, unless you were Caesar, but on average it was good to be the king. Everybody else was destitute. Everybody else lived a subsistence lifestyle. Every hour of every day, of every week, of every month, of every year. In order to eat, you had to run fast enough or throw something hard enough that it killed something that you could eat it. In order to fish, you had to extract the fish. There was no Tesco. There was no grocery store. There was no Uber Eats that you just on your phone, Tristan's laying in bed one night and says, "Oh my God, I got a craving for pizza." Doesn't even have to get out of bed. Pizza just shows up at the door. Since 1900, this is what global population has done. It's increased from slightly less than 2 billion people to now approaching 8 billion people on Earth. It's who we are. We have significantly increased the number of us on the planet. We have significantly increased the economic output for almost all areas of the planet. With variability, absolutely. There is still, and I think there always will be, the good, the bad, and the ugly. There are winners, there are losers. There are some areas of the world that have more rapidly grown their economic output than others. But these are universal truths. These are facts. Global population has increased significantly, and GDP, gross domestic product, which is not a perfect way to measure economic output, but it at least is a universal standard that economists use to measure economic output, has increased along with population. More people, more work, more product, more economic output. As a result, life expectancy in 100 years has doubled. And I say this to college students. Life expectancy has doubled. I turned 50 last November. 100 years ago, the average life expectancy on the planet was 50. One of my kids lovingly said, "Dad, you're now one day closer to death." And I thought that's true for all of us every day. Right? If you wake up, you're one day closer to when you'll die. But life expectancy has doubled, and we see this in every country around the world. Now, it's been variable. It has increased at slightly different rates in different places, but it's doubled. And that is the manifestation of prosperity, whether you want to accept it or not. If you don't want to accept it, you have to completely give up everything that makes our society tick. And there's a TV show called Naked and Afraid that will have you as a contestant. Why has life expectancy doubled? Because maternal mortality has plummeted. Modern medicine, we looked around. In the 1860s, there was a doctor in Austria named Ignaz Semmelweis. And Ignaz Semmelweis worked in a hospital that also had a morgue. And Ignaz Semmelweis, here's what he came up with. Women who gave birth and the doctor attending them, if the doctor had performed an autopsy the same morning when the woman gave birth in the afternoon, the rate with which those women died was significantly higher than women who gave birth first thing in the morning when the doctor had performed no autopsy. And he looked at that and thought there must be some transfer of something from the dead body that caused the death to the woman's vagina, and then that spread through the woman and killed the woman, typically within days of giving birth. So if we go back 150 years, we didn't even wash hands before performing surgeries. He figured this out, And over the last 150 years, we now have a medical system internationally where, on average, most women who go into a medical clinic to give birth, they don't die. The death rate was typically 1 out of 4, right? Much lower. We see the same thing with childhood mortality. When we read in history that women would have 8, 10, 12, 15 kids, typically a third of those kids would die by the age of 5. Dysentery. We literally would shit ourselves to death. It was horrific. But owing to modern medicine, we've seen childhood mortality plummet everywhere. We talk about extreme poverty, and depending on how you vote, you have a particular angle when you talk about extreme poverty. But the reality, again, was that for most of humanity, all of us were literally dirt poor. All of us eked out a subsistence lifestyle. All of us. 99.99999%. King and queen, you had it good. Everybody else, life was terrible. And the number of people living in extreme poverty has systematically decreased around the world. There are still problems, without any doubt. But the number of people who truly live in extreme poverty has decreased as a whole. We have access to electricity to thank for a lot of this. So if we look at data over the last 130 years, these are data for the United States and other developed countries, European Union, more developed countries. We only figured out how to produce electricity in the 1870s. Thomas Edison and his colleagues built 2 coal-fired power plants, one in London and one in New York City. And they figured out by using copper and a magnet, if you spin one around the other, you can push a charge along a metal wire. And when we look at access to electricity, we don't think about it in terms of how it has radically transformed society over the last 100 plus years. So the black line is the access to electricity. And we have the percentage of households that have access to electricity on the right. In the United States, it's 100%. Now, there are issues with people who cannot afford electricity, without a doubt. But everyone has access to electricity. The red line shows you that as a result of having electricity, we don't do as much work in the house as we used to. We used to live a subsistence lifestyle. Think about doing laundry in the 19th century. Think about how you accessed your food in the 19th century. Electricity has caused the average household to drop from needing to do about 60 hours a week at the turn of the last century to about 20 hours a week. Because of all of the things that we plug into. Washing machines, microwave ovens, stoves, hot water heaters, my battery electric vehicle. Electricity as a resource has radically changed who we are as a society. And I've done research on 7 continents and now about 70 countries. I have seen the uber wealthy in Liechtenstein and Switzerland, and I have seen the truly poor in sub-Saharan Africa. And I've never met somebody in sub-Saharan Africa who says, I don't want that. I don't want access to medical care. I don't want access to clean water so that when I shit in my toilet, I can push a button and it just magically goes away. 2 weeks from now, I'll be in Liberia with a former student who earned his master's degree with me. And that student, when he came to the United States, was the first time he ever left sub-Saharan Africa. And to say he was blown away is an understatement. He broke down in tears in our grocery store. Now, some of you might be bristling that I'm advocating for increased consumption. But he was amazed at refrigeration and how common it was. We take it for granted. And then some of us sit on our high horse and say, well, maybe they don't want it. I disagree. We work less. In the United States, we work typically 5 days a week, 8 hours a day. That's a standard work week. In France, I was in Paris last week, maybe they work a day a week and they start drinking wine at noon. It's off the charts in France. My 18-year-old daughter looked around and she said, Dad, is this what people do? They wake up, have breakfast at 10, and by 1 they're at the cafe drinking a glass of wine? And I said, that's what it is. It's amazing. But we do. We work less in the global north. As a result, we have more leisure time. Now, there's a difference in the amount of leisure time for men versus women, and this highlights gender inequality, which we still have to work on because gender inequality is far from where we want it to be. But it's much better today than it was in the past. This is one example of how we work differently. In the 19th century, it would take myself and 25 people in this room all day long to harvest and thresh a ton of grain. Today, we have machines that do that in 6 minutes. 6 minutes. And there's one person operating that machine, which means the other 24 people are doing other things. Now, that has created new problems. For example, today we see countries such as Somalia, where we have significant food problems related to Russia's war against Ukraine. So absolutely there are problems that we have created, but by and large they eliminated a major problem, which was a lot of people starved everywhere. So we look around the world, and the figure on the left is percent electrified versus time for the last 100 years. You can see the countries on the right: Brazil, China, Egypt, India, Mauritius, Sweden, Thailand, UK, USA, Vietnam. At different periods of time over the last 100 years, access to electricity has variably taken root in each of these countries, but it's gone to 100%. And then the data on the right, the same y-axis, and the average GDP. Now that's an average. Within any one country, there are the very elite wealthy and the middle class and the poor. The middle class was something that we created in the 20th century. There was never a middle class. There were the haves, and everyone else had not. Here are some examples of this radical change. Anybody who's been to Qatar, when you fly into Qatar, you see today the photograph on the bottom. If you went to Qatar in 1980, you would have seen the photograph at the top. What caused that change? What happened that Qatar went from effectively a Bedouin society, where through the 1960s, the major economic activity in Qatar was fishing and pearl diving? What happened is that scientists and engineers figured out that Qatar and other emirates had access to natural gas underground, and that natural gas could be extracted, cooled to a temperature of about negative 170 degrees C, where it transitions from a gas to a liquid, and that liquid natural gas can be exported. And Qatar, in one generation, went from having one of the lowest GDPs per capita on the planet to now having one of the highest. In one generation. We look at literacy rate in the Middle East and North Africa. Today, the literacy rate is approaching 100%. 2 generations ago, there was a very different literacy rate. So when we look at this image of the transformation of Qatar and its economy, and we look at the liberation of Algeria 60 years ago, what we're seeing here is economic growth, access to electricity, access to education, improving gender equality. It's not perfect. But I would think the fact, and I'm looking at you because I remember Murray announced you were from Algeria, like looking at you, 60 years ago, you probably wouldn't have been sitting here. And today you're here. Bangladesh, 60 years ago, you wouldn't have been here. Today you're here. Blows my mind. I think that's amazing. I think that's progress. We look at lights around the world, and they show us that progress is variable. We look at Africa, and some people would look at Africa and say, let's leave it the way it is. Very colonial attitude. Other people look at Africa, and if you've traveled throughout Africa, and you've met the amazing people in Africa who are just as smart as people in your neighborhood where you grew up, what I hear from them is, people die of kidney disease because we don't have electricity for dialysis. People die of diabetes because we don't have electricity for pumps to regulate insulin levels for diabetes. So my sister who has type 1 diabetes, she would have died long ago. But for the fact that she was blessed to be born in the United States, and so she has a little pump that automatically knows when her insulin levels drop. We think about COVID, the pandemic that swept around the world. I look at places in Latin America, Africa, Southeast Asia. The vaccines that I got, they have to be refrigerated. The absence of refrigeration is an absence of vaccines. So there has been tremendous progress, and we have a lot more work to do. So when we look at global population and we look at economic output, they've increased. There are a variety of ways to measure prosperity. This is one of them, referred to on the y-axis as the Human Development Index, versus the x-axis is per capita primary power consumption. And the interpretation here would be that the more energy that we consume in a given country, the more prosperous we are. And that relationship holds. You can tweak it here and there and you can criticize it, but the relationship holds. And if I look at a country such as Zambia, I'm pretty sure if I went door to door in Zambia, most Zambians want to have access to medical care, to education, gender equality, democracy. So there's work to be done. And for all of us who sit up here and think that we don't have work to do, that's where we have to get off of our moral high horse and get involved. Because when we look at global access to electricity, the country Liberia, about 1% of their population has access to secure, reliable electricity. Again, for those of us blessed to have been born into a country where from day one we had access to everything, it's important to look through the lens of people from other parts of the world that, owing to historical systemic racism, have been disallowed from making the same progress that we have made. And I suggest that it's our moral imperative that we have to help. This is a snapshot of the reliability of grid electricity in households in Africa that are connected to a grid. If you travel throughout sub-Saharan Africa, it's common to hear diesel generators. And when you hear diesel generators, you're hearing them because the grid is not operating. It's common for children to lack access to the same education that my 2 daughters and my 2 sons have. I've worked on this in Ghana. We call it the digital divide. Students in the United States that from the time they're 5 years old, they walk into school with this, whereas students in rural Ghana have no access to any technology, which manifests in their being less competitive to get into college and to get jobs and to attract companies. Now, along with global population and increased economic output, there is a correlation with increased consumption of fossil fuels. And when we talk about the energy that we have consumed that has been the cause of prosperity, fossil fuels have been that energy. But fossil fuels do not have to be the primary source of energy moving forward. Fossil fuels do not have to be the primary source of energy in Zambia, or in Algeria, or in the United States. Just as humans transition from the Stone Age to the Copper Age, to the Bronze Age, to the Iron Age, we're living through a transition now. We're adding capacity with respect to renewable energy. Our total energy consumption is going up, and as I mentioned earlier, our ability to increase capacity of renewable energy right now is hobbled politically. When we look at the last 160 years, this is what we've done with And you look at this and look at the wood that we burned. Wood was the primary source of energy. Right? If you lived in the European Union and the United States and Canada in the late 19th century, whale oil was what you used to illuminate your home at night. And most boys would go into whale hunting industry by the time they were 10, 11, 12, 13 years old. We don't hunt whales anymore for the purpose of extracting their oil, their blubber. So we see about 1900 coal displaces wood, right? And they're both basically carbohydrates. Right? Wood is a fossil fuel, C6H12O6, and we extract the energy tied within those bonds. Coal is carbon-carbon bonds. We extract that energy, which is an exothermic reaction. We see crude oil really start to take off after World War I to World War II and beyond. So when we think about humans over hundreds of thousands of generations, in the span of less than 10 generations, we have completely changed who we are. And anytime progress or change happens rapidly, we make mistakes. Without a doubt, anytime you rush a decision, you make a rash decision, you do something instantaneously, mistakes are bound to happen. We currently consume 100 million barrels of oil every single day. It's the most traded commodity on the planet, 100 million barrels every single day. Right? We consume phenomenal quantities of coal and natural gas. We're starting to see here wind and solar on the bottom, which are really small parts of our global primary energy infrastructure. We're starting to see them grow. In order for them to grow faster at the speed that we need them to grow, if we agree that we want to replace fossil fuels with renewable energy, then the collective we have to work to remove the obstacles that right now limit exploration and mining. So what are the positive and negative consequences of prosperity?
There were slightly more than 100,000 harness and carriage makers. By 1930,
So if you look at the image on the left, 1900, New York City, there's one combustion engine vehicle. If you look at the image on the right, everybody's driving a combustion engine vehicle 13 years later. And you'd think to yourself that was great. And I'll tell you why it was great. Because in 1900, the primary mode of transportation was horses. Horses defecate a lot. So through the late 19th and early 20th century, pick a city in Europe, in the United States, where the primary mode of transportation was horses, and read about the public health crises with respect to groundwater contamination. Dysentery was common. Death by dysentery was common. Right? So this transition happened in a decade. We hear a lot of criticism of renewable energy because it's going to put people out of work. Well, we put out of work all of the people that made buggies and carriages. Right? In 1900 globally, there were about 250,000 people around the world whose job it was 6 days a week, typically 12 hours a day, to make buggies and carriages. They don't have those jobs anymore. The same thing happened with blacksmiths. Think about how many blacksmiths there used to be. We don't have them anymore. So when you hear criticism about renewable energy, quote, killing jobs, well, it's true, but it also creates jobs. I mentioned literacy rates earlier, so I'll skip that here. This is Shanghai in 1987. This is Shanghai in 2013. Right? And what you see are buildings. Okay, yeah, we've built some buildings, and must mean we have more steel that we're consuming and more cement that we're consuming. But I'll show you how this manifests in ways that most people don't think about. If you go back to 1980 and you look at the population of Chinese students enrolled in U.S. universities, it was about 0. Today we have several 100,000 Chinese students in U.S. universities. That tells you about economic growth in China, where China transitioned from a third world to a first world, second leading economy in the world. And as a result of that economic output and prosperity, China has now created a middle class in 2 generations, and that middle class has the financial ability to send hundreds of thousands of students to study in the United States. I think that's progress. We made mistakes. All of that coal that we used to burn, we would also, along with the coal, we would combust sulfides. Sulfur plus oxygen produces sulfur dioxide, and sulfur dioxide in the atmosphere leads to acid rain. The images on your left are sulfate and hydrogen ion concentration of rainwater across the United States. It was really bad 30 years ago. And then we ideated scrubbing mechanisms for sulfur dioxide, and as a result, the emissions of sulfur dioxide in the United States and globally plummeted. They're not 0, but they're much closer to 0 than they were 30 years ago, and you see that in the results on the right. Same sample areas, completely different result. And I want to highlight that in the United States, if I were to ask you, was it the conservatives or the liberals who proposed regulations for sulfur dioxide, what would your answer be? Intuitively, you would think liberals, but it was actually the opposite. Conservatives had to lobby liberals to use regulation to incentivize engineers to develop pollution controls. We've talked about mining. This is another example where regulation worked. If we go back 100 years and simply look at the blue bars, they represent the number of people who died mining coal in the United States. And on the right-hand side are the sequence of regulations agreed upon by conservatives and liberals that have significantly reduced the number of fatalities. So whenever I hear someone say regulations are burdensome, I always ask them to define burdensome, because I look at the number of fatalities decreasing significantly as a result of automation, ingenuity. We are producing more and fewer people are dying. But this is the big negative. The black lines back here are coal, oil, natural gas. And it's a really simple calculation to go backwards in time and tally up the total amount of coal that we've mined, the total amount of oil that we've mined, the total amount of natural gas that we've mined, and then do the calculation that during combustion, all of the carbon in those fossil fuels is emitted to the atmosphere. So the red line is how much carbon we have put into the atmosphere since the Industrial Revolution. And we know unequivocally today, 100% of rational, logical scientists agree that as you increase the abundance of carbon dioxide in the atmosphere and methane in the atmosphere, that traps long-wave radiation that is re-radiated from Earth's surface and causes warming of Earth's troposphere. And as a result of the exchange of carbon dioxide between the troposphere and the oceans, acidifies the oceans. We know this today. And as a result, there is tremendous discussion about carbon neutrality. What does it actually mean? What is carbon neutrality? If you read in detail all of the scientific reports, and most of them are excellent, where they model the rate of increase of carbon dioxide in the troposphere and what its effect will be trapping long-wave radiation, causing temperatures to increase. We know that by 2050, we're on track now for global temperatures, average global temperatures, to increase by at least 2 degrees Celsius. And we know that the only way for that not to happen is to take this red line back to zero. And there are 2 ways that can happen. Well, there are 3. We all live naked and afraid. And trust me, you don't want me to do that. 2, we continue to combust coal and oil and natural gas, but we capture the CO2 at the point of combustion and pump it back underground, something we call carbon capture and storage, or carbon capture and sequestration. Or we rapidly expand and increase the amount of renewable energy that we have. Now, politicians love to create goals. Politicians rarely deliver on those goals. But this is just a snapshot of every country on the planet by 2060, China and India included, going to be carbon neutral. And it sounds great. People get elected on this platform. We're going to be carbon neutral by 2050. Yes, sir. And I step back and say, okay, how can that happen? I read the Green New Deal, carbon neutrality, all primary energy, carbon neutrality. And I keep saying primary energy because it's often confused with secondary energy. Secondary energy is electricity. It's much easier to imagine a scenario where we simply replace the current electricity grid with renewables. Carbon neutrality requires that all fossil fuel combustion essentially be negated, either by carbon capture, planting a bazillion trees, okay, where a bazillion is 10 to like the bazillion. Okay? We're nowhere near on target to meet our goals. Nobody is. Despite the rhetoric that we publicize, no one, I think, except for Bhutan, is on target to meet their sustainability goals. But they sound great. Right? The Biden administration puts something out, oh my God, it sounds great, and everybody has a party. Right? The European Union comes together and they're like, oh, what are we going to do? Let's become carbon neutral. That sounds awesome. Jump on the jet and go home. All right? People, on average, want this change. So here's just, if I take a snapshot in the United States, if you talk with people one-on-one, so you eliminate groupthink, one-on-one, an overwhelming majority of people in the United States want to transition to renewable energy, which tells us that the public will is there to make it happen. When you look at the data, I want to give you some hope. This is the total installed wind electricity capacity in the United States. So think of a higher number means more wind turbines in each of these states. And I want to highlight that the state that dominates is down here, is Texas. And then look at all of these states that I'm highlighting here. Do you think those are conservative or liberal? What's your guess? They're all conservative. Every one of those states is conservative. Every one of those states voted for Donald Trump. But we see this significant growth in wind energy, secondary electricity, in the United States and around the world. And it's happening fast in areas that are conservative. It's not happening fastest in areas that are liberal. And this is where I want to introduce the term cognitive dissonance, where people say one thing and you present them with a viable, practical, economical solution, and they run away. They run away. When we look in the United States as an example, what we call the red states that vote conservative, those are the states where renewable energy is taking off. And the reason it's taking off in those states is purely economic. I've never met a conservative, a Republican, who is pro-business, who will turn down a way to reduce their energy budget. So when we look around the world at the cost of building new energy infrastructure, what you see here is that building new energy infrastructure, the cost is certainly variable, but renewables are less expensive than fossil fuels, which is why all of these states that will tell you in a group they're opposed to renewable energy are not. So this is back to somebody who was in our group yesterday. We were talking about human psychology, right? So this is my house, Ann Arbor, Michigan, a place that's really cold in the winter and not so hot in the summertime. And this is my wife every day, comes home, 3 days a week she's on campus, 2 days she works from home. She gets out of our car and she plugs it in. This is the other reason renewables are taking hold in conservative areas. Convenience. Buying back your time. Never have to fill up with petrol, which I can tell you, do a swab test at the petrol station. It's just disgusting. The bacteria and viruses on the little pump. So every day, my wife, or if I'm driving, drive home, we plug in. I built solar in the backyard. I've got 6 lithium iron phosphorus batteries in the basement, and I'm off the grid. I can do it. So what resources are required? Okay? Not as much as you think. So in one of my classes, I spend the entire semester with students using GIS to model the spatial footprint, the land. Land is a resource. The land required for renewables to generate all of the energy we consume. And in my part of Michigan, this land that you can see colored, the darker color in pink is utility scale solar, the lighter color is wind. If every vehicle is an electric vehicle, if all of our home heating and cooling is electric, everything is electric, that's what we need. So we don't need that much space. And when you price in batteries, it's marginally economic now, but increasingly becoming more economic. The problem is we don't have universal support for building the renewable energy infrastructure. So this is Ann Arbor, Michigan, a very, very, very liberal part of the United States. And when homeowners started putting solar panels in their front yard, whoop, missing a slide here, the city council
Michigan
created an ordinance to
solar
ban
installations in residential front yards. Now,
most of the people I know think that this is where you get solar panels. They somehow grow on trees at the organic orchard, and you go on a Saturday and you pick some apples and peaches and pears, and then there's a solar panel row. Let me pick a few solar panels and take them home. Solar panels and every other part of our renewable energy infrastructure require lots of resources, and they have to be mined. I think someone yesterday or Tuesday or Monday mentioned how much more copper we need, so I'll just use that as the example, and I know I've only got a couple of minutes. But if we look at where the resources come from, they come from here. And this triggers an emotional response in people. It's ugly, it's a scar, it's a scab, it's bad, it moves people. It triggers that emotional response, and that is what results in the cognitive dissonance. With people who want renewable energy because they don't want fossil fuels, but the only way that we can build renewable energy is by mining. And we're already embarking on a supply shortage. So if we look right now at all of the mines globally that are permitted and currently operating and permitted to go into operation within the next decade, we already can't meet the European Union goals. We already can't meet the USA goals. We can't do it. So we have this cognitive dissonance where people want wind turbines, want solar panels, but they don't want any mines. And we see the same thing for every metal required for renewable energy. If you calculate the supply of that metal right now to 2050 divided by demand, it's less than 1, which tells us we can't meet our goals. Mining companies are not finding as much metal as they once did. Budgets have increased on average over the last 100 years, but it's on average taking 16 years to go from discovery to production. It's 2022. 16 years is 2038. So that means if I discover a copper mine today, on average, it's 2038 before I've built my infrastructure. Now, why is that? Part of that is because of the economic impact assessment, which we have to do. But much of that is just bureaucratic delay. And the bureaucratic delay is put in place by people who advocate for renewable energy. So what we have to have happen, and I saw this in this room on Tuesday morning when we all did that Mentimeter survey, and it asked us, I forget the exact wording of the question, but something along the lines of, what is your perception of the mining industry? And it was neutral. A majority of people in the room were neutral. And I look at that and think, really? I would have expected everyone in here to be gangbusters, advocating for mining, full on, with environmental impact assessments, not at the expense of people per se, right? We don't want to move communities without their consent. But the neutrality tells us why right now we cannot make our deadlines. And it's because a majority of people on the conservative side, they're pro-renewables because it's economic. We already won them over. We've won the conservatives over. But we haven't won the liberals over, for whom climate change is an existential crisis. And if climate change for you is an existential crisis, then you have to fully get on board and advocate for responsible mining at a scale that we have never known before. Because if you don't do that, in essence, you accept the climate change that results. And I'll stop there. Thank you.